Pressurization system on the A330 normally operates automatically to adjust the cabin altitude and rate of change of altitude to ensure maximum passenger comfort and safety. Pressurized areas are the cockpit, the avionics compartment, the cabin, and the cargo compartments. The concept of the system is simple. Air is supplied from the air conditioning packs to the pressurized areas. Two outflow valves are used to regulate the amount of air allowed to escape from the pressurized areas. Automatic control of the outflow valves is provided by two cabin pressure controllers. Each controller has an electric motor to move each outflow valve. The combination of a controller and two motors is known as a system. Only one system will operate at any one time, with the other system acting as backup. A third motor is installed on each outflow valve for use in the event of failure of both automatic systems. A manual input is required to open or close the outflow valve. Safety valves are installed to avoid excessive cabin differential pressure. Let us look at the operation of the outflow valves for an aircraft in cruise, and what happens to cabin differential pressure, cabin altitude, and cabin vertical speed. We will start with cabin differential pressure. If the outflow valves are closed, or only allowing a small amount of air to escape, then the cabin differential pressure will increase. Now let's look at what happens to cabin altitude. If the outflow valves are closed, or only allowing a small amount of air to escape, then the cabin altitude will descend. We can also see what the cabin is doing by referring to the vertical speed. When the outflow valves close, the cabin altitude will decrease with a negative vertical speed. If the outflow valves are fully open, a lot of air is allowed to escape. The cabin pressure will decrease. The cabin altitude will increase with a positive vertical speed. The crew can monitor all cabin pressure functions on the ECAM cabin pressurization page. Let's look at the information associated with the pressurization system that is presented on the cabin pressurization page. The pack indication is displayed green when the associated pack is on. The outflow valve's position can be monitored, and the system controller in use is shown. There is a single indication for the two safety valves. We will look at how this indication changes in the abnormal operation module. The cabin differential pressure, or delta P, shows the difference in psi between the cabin pressure and external pressure. This differential pressure will be at zero on the ground and increase as the aircraft climbs. The cabin vertical speed shows the rate of change of cabin altitude in feet per minute. For passenger comfort, the pressurization system will aim to keep this rate of change as small as possible. The cabin altitude is also shown. The vent extract and ground cooling indications are associated with the avionics ventilation system and will be discussed in a separate module. On the ECAM cruise page, there are indications of cabin differential pressure, cabin vertical speed, and cabin altitude. The cabin vertical speed is also indicated on the ECAM door page. Note that this indication is only displayed when the aircraft is airborne. On the overhead panel, the cabin pressurization panel contains controls to operate the pressurization system. Under normal conditions, no pilot action is required on this panel during flight. The pressurization mode select switch has two settings, automatic and manual. The normal position for this switch is lights out. In this position, the pressurization system is in automatic mode. The use of manual mode, the manual vertical speed control, and the valve selector will be discussed in the abnormal operation module. The landing elevation selector normally remains in the auto position. Landing elevation, which is required by the pressurization system, is then provided by the FMGS based upon elevation of the destination airport. If the landing elevation is not available from the FMGS, then it can be set manually using this selector. You will use this selector in the abnormal operation modules. The guarded ditching switch is provided to close all valves below the waterline, so that the aircraft can be sealed in the unlikely event of a ditching. Now look at the normal operation of the pressurization system. As part of your pre-flight walk-around, you should visually check the outflow valves for damage and obstruction. As part of your pre-flight cockpit scan, verify on the cabin pressure panel that the mode selector switch is in the auto position, lights out. Confirm that the landing elevation selector is set to automatic. Landing elevation is then provided by the FMGS based upon elevation of the destination airport. Also confirm that the ditching switch is in the off position, lights out. On the ECAM cabin pressurization page, confirm that the landing elevation indication is auto. Once the destination airport has been entered into the FMGS, the destination landing elevation is displayed. Notice that there are no amber indications. So that you can get a better understanding of how the pressurization system works, we will go through a normal flight profile, paying particular attention to the ECAM indications. The aircraft is on the ground before the flight. We can now look at the ECAM cabin pressurization page. Observe that the outflow valves are fully open. The differential pressure is 0. There is no vertical speed, and the cabin altitude is indicating the field elevation of the departure airfield. During the takeoff roll, the system controller signals the outflow valves to close slightly in order to pre-pressurize the aircraft. This is to avoid a pressure surge at rotation. At liftoff, the controller initiates the climb phase, and cabin altitude varies according to a fixed law taking into account the actual rate of climb of the aircraft. The outflow valves will move as required to achieve this. Once established in cruise, the cabin altitude and differential pressure will remain steady. The outflow valves will move as required to maintain the cabin altitude. In the example shown, the aircraft is in cruise at 35,000 feet. Notice the values of differential pressure and cabin altitude. While in flight, we can monitor all the major pressurization indications on the ECAM cruise page. During the descent phase, the pressure rate is optimized so that the cabin reaches landing field pressure just prior to landing. Note, for passenger comfort, the automatic function will limit the rate of cabin descent to a maximum of approximately 750 feet per minute. At touchdown, the cabin altitude should be at the airfield elevation, and there should be no differential pressure. To ensure this, just after landing, the outflow valves are fully opened by the system controller. Once the outflow valves are fully open, there is an automatic changeover of the system controllers in preparation for the next flight. This happens so that both systems are used equally. This is an example of an abnormal procedure. We will use a cabin pressure fault where one of the two automatic systems fails. At this time, the aircraft is in cruise and all systems are functioning normally. You are the pilot non-flying. On the engine warning display, read the title of the failure. The ECAM caution, Cabin Pressure System 1 fault, appears amber, meaning that Pressure Controller System 1 is faulty. Notice that the ECAM cabin pressurization page has been automatically called, with System 1 indication in amber. Due to the fact that this is only a crew awareness, there was no master caution. As you can notice on the engine warning display, there is no action required by the crew. System 2 is automatically activated and controls the outflow valves, as shown on the ECAM page. The pressurization system is now analyzed. After review and confirmation from the pilot flying, clear cabin pressurization. The status page is now displayed. There are no approach procedures to follow, and the inoperative system is Cabin Pressurization System 1. After review and confirmation from the pilot flying, clear status. ECAM action completed. The status page is replaced by the cruise page. Let's look at a second failure to illustrate the functionality of the system, the associated indication and the ECAM procedure. We will use a dual system fault to illustrate these procedures. The aircraft is in cruise at flight level 350. On the engine warning display, read the title of the failure. This time, both pressurization systems have failed. Once again, notice that the ECAM cabin pressurization page has been automatically called. As you can see on the ECAM cabin pressurization page, both System 1 and System 2 indications have turned amber, meaning that both automatic systems have failed. Notice that the amber fault light is illuminated on the cabin pressurization panel. The pilot flying will ask you to perform the ECAM actions. Perform ECAM action. On the cabin pressurization panel, the amber fault light extinguishes and is replaced by the white MAN light. On the ECAM page, the MAN messages appear in green above both outflow valves to indicate that they are under manual control. As the manual valve selector is already on both, its normal position, the corresponding line is automatically removed on the engine warning display. As it is indicated on the engine warning display, you have now to manually control the pressurization of the aircraft by using the manual vertical speed control switch to move the outflow valves. Notice also that since you have control of the outflow valves, the landing elevation indication is no longer displayed. Let's pause the ECAM procedure and look at the use of the manual vertical speed control switch. The manual vertical speed control switch is spring-loaded to neutral. If you hold the switch in the up position, the outflow valves slowly open, the cabin vertical speed will change, and the cabin altitude will increase. When the manual vertical speed control switch is returned to the neutral position, the outflow valves will stop moving, the cabin vertical speed will stabilize, and the cabin altitude will change. Conversely, if you hold the switch down, the outflow valves will close, the cabin vertical speed will change, and the cabin altitude will decrease. Now let's return to the ECAM procedure. Notice that the cabin vertical speed indication is 0. This means that there is no need to adjust the outflow valve's position using the manual vertical speed control switch. Because you have to continually use the manual vertical speed control switch, the action line is not removed. The pressurization system is now analyzed. After review and confirmation from the pilot flying, clear cabin pressurization. The status page provides the pilots with the following information. target vertical speeds, target cabin altitudes, which depend on the flight level, and a final approach procedure to set the vertical speed control fully up. This ensures that the outflow valve opens completely and the aircraft depressurizes. For our example, we are at flight level 350, so the target cabin altitude is 6,500 feet. Review the inoperative systems in the right-hand column. Remember that information will remain on the status page for the duration of the flight and can be reviewed at any time. The information on the status page is very useful during descent. You will need to control the outflow valve and adjust the cabin vertical speed to reach the target cabin altitude. After review and confirmation from the pilot flying, clear status. ECAM action completed. Notice that on the cruise page, the indication of the cabin vertical speed has changed to a gauge format. This, along with the cabin altitude indication, can be used to set the correct position of the outflow valves. Let's now assume that air traffic control has asked you to commence a descent to flight level 290. Call the status page. Note that the target cabin vertical speed for the descent is 300 feet per minute, and at flight level 290 the cabin altitude target is 4,500 feet. Deselect status. The descent has started. The manual vertical speed control switch should be selected to establish a cabin vertical speed of 300 feet per minute down. Select the manual vertical speed control switch. The switch is held down until the cabin vertical speed reaches the target of 300 feet per minute, and then released back to the neutral position. The cabin altitude is now decreasing. Approaching the target cabin altitude, the manual vertical speed control switch is selected up to decrease the cabin vertical speed. Some fine-tuning may be required using short blips of the manual vertical speed control switch. You will have the opportunity to practice the use of the manual vertical speed control in the simulator, so we will stop here. In this module, we will look at some other abnormal situations of the pressurization system. This is an example of an abnormal procedure. The aircraft is in cruise and all systems are working normally. Now, to extinguish the master caution light, push the master caution push button switch. On the engine warning display, read the title of the failure. The ECAM caution, landing elevation fault, appears amber, meaning that the pressurization system has, for some reason, lost the landing elevation data normally supplied by the FMGS. Notice that the ECAM cabin pressurization page has been automatically called with no value for the landing elevation. In this case, you have to set the landing field elevation manually. The pilot flying will ask you to perform the ECAM actions. Perform ECAM action. As soon as the selector is moved from the auto position, the action line on the engine warning display clears, and a MAN message appears on the cabin pressurization page. The landing elevation value will also indicate the selected value. The pressurization system is now analyzed. After review and confirmation from the pilot flying, clear cabin pressurization. ECAM action completed. Notice that there is no call of the status page because we have set the landing elevation manually and the system is operative. And there is a manual landing elevation indication on the cruise page. To complete this module, let's look at some other abnormal indications and what they mean. If there is an excessive positive or negative differential pressure, one of the safety valves will operate. An ECAM caution cabin pressure safety valve open is generated, and the safety valve indication on the cabin pressurization page changes to amber. An ECAM caution cabin pressure forward outflow valve not open will be displayed if the forward outflow valve has not fully opened on landing. This could mean that the aircraft is depressurizing at a slower rate and that the doors may be difficult to open. In that case, you have to take manual control of the faulty outflow valve by using the valve selector guarded selector. In all other cases, the indications on the cabin pressurization page will change to amber for abnormal indications apart from the cabin altitude indications. However, if there is an excessive cabin altitude, the indication turns red and a master warning is generated.